Opening music, slow, resonant synth chords fade in. Visual, a beautiful, smooth animation of a light ray traveling perfectly straight. The speed of light. It is the ultimate constant. It is the boundary of all possible speeds. For millennia, the universe operated under this fixed law. Light zipped across the void at 299,792,458 meters per second. This speed defined causality itself. It meant that what we see now happened in the past. This speed was absolute, unchanging, and foundational. But what if it was not? Imagine a moment utterly silent when this cosmic speed limit simply dissolved. Imagine light suddenly drastically slowing down. Not by a little, but perhaps by a factor of 10,000. The universe does not immediately end in fire. Instead, it begins a slow, terrifying transition into a new reality governed by lethargic photons. This is the world where the speed of light is merely the speed of sound, perhaps even slower. This is the story of the Great Lag. The hook, the change. The alteration is not violent, but pervasive. It begins subtly, perhaps as a slight fuzziness in distant stars. One instant, the world operates as we know it. The next instant, the fundamental constant of physics has been downgraded. The universe has developed a universal, pervasive lag. Everything that relies on electromagnetism now functions under a profoundly sluggish new rule set. The first tangible sign is optical. Look at your hand. The light reflecting from your skin now takes a perceptible fraction of a second longer to reach your eye. It is minuscule at first, barely registering above the natural flicker of human perception. But then the shift accelerates, or perhaps the slowness becomes more pronounced due to atmospheric refraction effects we never accounted for. Consider the sun. Sunlight, which usually takes 8 minutes to cross the void, now takes hours, perhaps days. The direct, bright sensation of noon vanishes. The solar disk appears immense, not because it has expanded, but because its light is smeared across a much larger angular area as it travels slowly toward the observer. It is a vast, dim watercolor wash across the sky. The first ripples, the immediate aftermath. The first hour is dominated by confusion, not panic. People notice strange visual echoes. When you turn your head quickly, the visual information lags behind the physical movement. It feels like moving through thick, invisible water. Your brain struggles to reconcile the proprioceptive input with the delayed visual feedback. Spatial awareness collapses instantly. Peripheral vision becomes nearly useless. Any sudden movement in your side view generates a confusing smear of light and shadow that arrives too late to inform immediate reaction. Standing upright becomes a complex motor skill requiring intense concentration. Falling becomes commonplace. Television screens, which rely on rapidly refreshing pixels, become chaotic. The image refresh rate, once far exceeding the speed of light, is now far slower than the displayed refresh cycle. Screens display shimmering, ghosted images, vast swathes of delayed information overlapping current transmissions. Broadcast television effectively ends in a slow-motion kaleidoscope of outdated frames. Within the first day, the communications crisis begins. radio waves, being electromagnetic radiation, are equally affected. Radio communication slows to a crawl. A simple conversation across a city now takes minutes to complete. International communication becomes impossible in real time. Ships at sea, reliant on radio guidance, drift aimlessly until their internal inertial navigation systems take over, assuming they are still functional. The electromagnetic spectrum has become sluggish. This profoundly impacts technology that requires rapid photon exchange. Computers rely on the near instantaneous travel of electrons and photons across circuits. If the speed of light slows, the speed of electrical signaling slows proportionally. Modern microprocessors become antique curiosities overnight. A processor clocked at 3 GHz assumes a cycle time dictated by light travel across a circuit board. If light slows by a factor of 10,000, that 3 GHz processor effectively becomes a slow calculator running at 300 kHz. Data transfer rates plummet. The Internet, that vast, instantaneous web of global connection, freezes into a collection of local, glacially slow networks. Downloading a document takes weeks. Systemic collapse, the breakdown of order. The next stage involves the breakdown of complex, interconnected systems. Power grids, synchronized by precise timing signals dependent on fast light pulses, begin to suffer catastrophic resonance failures. The stability mechanisms designed to handle momentary fluctuations are useless when the fluctuations themselves arrive slowly, out of sequence. Blackouts spread not quickly, but with an inevitable creeping darkness as stabilization fails. Consider the weather. Weather patterns are driven by solar energy input and complex atmospheric dynamics. The sun's light, now arriving days later, creates a thermal shock. The previous day's energy budget arrives long after the atmosphere has cooled or heated based on the current slower input. Global temperature regulation fails violently. Areas experiencing night might suddenly receive the full thermal energy of a long-delayed midday, causing rapid, localized boiling or intense evaporation before the system can adjust to the next day's slow arrival of cooling light. Biological processes are deeply intertwined with light speed through chemical reaction rates dependent on electromagnetic interactions. While biology is inherently slower than electronics, the fundamental energetic transitions, the very way molecules bond and release energy through photon exchange, are now subject to this universal drag. Photosynthesis, the bedrock of almost all life, becomes drastically inefficient. Plants still work, but the process of capturing sunlight and converting it is severely impeded by the molasses-like pace of the photons involved. Plant growth slows, leading to widespread crop failure within weeks. Human society relies on complex synchronization. Financial markets, once running on milliseconds, seize up entirely. Transactions take geological timescales to confirm across continents. The concept of immediate currency exchange evaporates. Trade reverts to localized barter systems, relying only on what can be physically moved slowly across the ground. The visual distortions become permanent and disorienting. Objects in the distance appear unbelievably smeared. Looking at a mountain range miles away is like looking at a photograph taken through a kilometer of swirling jelly. The light rays from the near edge of the mountain arrive noticeably before the light rays from the far edge, creating an impossible visual relief where depth perception dissolves into chaotic color gradients. The human perspective, living in the lag. For an individual survivor, life becomes an exercise in extreme patience and minimal action. Movement must be slow, deliberate, and planned. Running is dangerous because the visual warning of an obstacle arrives long after the obstacle itself has been struck. People learn to navigate by touch, sound, and memory of fixed environmental layouts. Imagine trying to have a simple conversation. You ask a question. You wait 10 minutes. The person hears the question, processes it internally, formulating a response. Then they speak. Their voice, carrying sound waves which are much slower than light but still faster than the new light speed, might arrive clearly. But your brain receives the visual cue of their mouth moving delayed relative to the sound arriving. Or perhaps the light from their face arrives so late that the visual context of their speaking mouth appears to belong to a movement they completed minutes prior. Social interaction collapses into a series of long, asynchronous exchanges. Trust must be built on long-term, verifiable observation, not quick judgment. Emotional reading becomes obsolete because the expressions on faces are history when they reach the observer. Suspicion breeds rapidly in this environment of perpetual delay. Architecture changes out of necessity. Tall buildings become hazardous. The light hitting the top of a skyscraper takes significantly longer to reach the ground floor than the light hitting the base. This differential creates an impossible visual shear. Buildings appear warped, leaning away from the light source in a constant slow-motion collapse that never resolves. Humans migrate towards single-story, modular structures built close to the ground to minimize the arrival time differential of light across surfaces. The sky, once a comforting blue dome, is now a source of deep existential dread. If the sun is very slow, the entire atmosphere is illuminated by ancient light. The blue sky, the result of Rayleigh scattering, still exists, but its color is muted, aged. The illumination feels thin, borrowed from a past moment the world has already moved beyond. When night truly falls, it does so not with a swift descent, but with a gradual, terrifying fading as the last of the slow-moving photons are depleted or scattered away. The long view, a cosmic isolation. Zooming out, the cosmological implications are staggering. Stars are no longer points of reference. They are vast, unpredictable historical archives. The nearest star, Proxima Centauri, is 4 light-years away. If light slows by a factor of 10,000, that distance might now take 40,000 years to traverse in terms of light travel time. The observable universe shrinks dramatically. We are effectively trapped in a solar system suddenly sealed off from the galaxy. The light from the Milky Way's center, once 80,000 years old, now takes millions of years to arrive. The past of the cosmos becomes infinitely inaccessible. Every flicker of distant light is a relic from a time that holds no bearing on the present mechanics of our immediate environment. Causality within the galaxy is severed. Gravity, which travels at the speed of light, experiences the same delay. This is crucial. If the sun were to vanish right now, the Earth would not feel the gravitational change for years, perhaps decades, depending on the exact magnitude of the speed reduction. The Earth would continue orbiting a phantom star, the orbital path dictated by ancient gravitational configuration. When the gravitational wave finally arrived, the Earth would be flung out of its established trajectory, perhaps spinning wildly into the void before the final collapse of the solar system's gravitational harmony. The universe becomes profoundly local. Reality is defined by the small sphere around you where light can still travel fast enough to sustain recognizable interaction. Beyond that localized bubble, the universe is a museum of ancient history, perpetually out of reach. Even fundamental concepts of observation change. Scientific measurement becomes an act of historical record-keeping. Scientists are no longer observers of the present. They are archaeologists charting a reality that existed yesterday. Experimentation yields results so delayed they cannot guide immediate decision-making. The entire engine of scientific progress stalls. The existential weight of this lag is crushing. Human consciousness demands real-time feedback to maintain its coherence. When that feedback is stretched across hours or days, the sense of self begins to fray. What is now when the input defining now is so delayed? Memory and anticipation become the primary modes of existence, filling the void left by the absence of immediate sensation. The human mind, designed for a universe of instantaneous response, struggles to process a reality governed by geological timescales of visual information. Conclusion: the slowed universe. The universe, under this new physics, is not dead, but it is profoundly isolated. The rapid, vibrant chaos of our initial reality is replaced by a deliberate, heavy stillness. Evolution itself, dependent on rapid environmental feedback, would slow to a glacial pace, favoring organisms capable of vast periods of suspended animation, or those whose energy needs are minimal. Humanity, the species that mastered speed, is now forced into slowness. Survival hinges on embracing minimal energy expenditure and accepting deep temporal disconnects. We learn to live in the past that our eyes finally deliver to us. We become creatures tethered to echoes. Yet, in this radical deceleration, there is a strange, stark beauty. The sky, though ancient, is permanent. The slowness forces contemplation. There is no hurry because haste is punished severely by confusion. The struggle for immediacy, the driving force of the industrial and digital ages, is rendered meaningless. We are left with the slow burn of existence itself. If light is slow, then time, in a practical human sense, stretches. We gain duration, even if we lose immediacy. We are forced to inhabit moments fully because the next moment's visual confirmation is so far away. We are ejected from the stream of rapid novelty and stranded in a timeless, deliberate present. The universe has become slow enough for us to finally catch up, not by moving faster, but by learning to wait an epoch for the next sunrise. This new reality demands acceptance. It demands a profound shift in what it means to be alive. We are no longer defined by how quickly we act. We are defined by how long we can endure the wait for the light to arrive.